rest of the week, we're just going to do a little bit of taste into chapter 12, just 12.1. And then tomorrow, we're going to do a little multiplication fluency with an Easter theme attached to it here, a little Easter egg hunt that has to do with some multiplication fluency. So look for that tomorrow. And besides that, I wanted you to know that once we return from Easter break, it's going to be April, and April is math month. And so we have some fun activities planned for the month of April, including something the fifth graders are assisting the whole school with on Data and Graph Day. You are going to be creating a survey poster project, either on your own or with one other person, and all of the poster surveys will be in the cafeteria for the other classes to come and participate in. So it'll be a really fun day. When we get back from Easter break, we will have some time to learn more about the project and get busy and have it all prepared before Data Day, which is towards the end of the month, okay? Does that sound fun? All right, good. So what we're going to need today is your workbook and maybe multiplication chart if you feel like you lean on that a little bit. So maybe multiplication chart. And that'll do it. We're going to open our workbooks to page 195. And I'm pulling up the workbook page right now. There we go. All right. So this should remind you a little bit of that bingo game that we played last week, where we practiced our kind of place value understanding, where when you multiply times a power of 10, whether it's 10, 100, 1,000, a million, 10 billion, when you multiply times a number that has that format, the digits don't change. Their position just does. So their place value changes. Some people like to think of it as the digits are moving, and some people like to say that decimal point is shifting. And you can see that here on the workbook page, where the author has chosen to use sort of the arrow technique to show the decimal point is shifting through those digits and lands in a new location. So if we take a look at this first example up at the top, we can see that the decimal 165 10,000ths is being multiplied times 1,000, which is equivalent to 3 place values, right? So we're going to basically pull those digits into bigger place values 3 times. And it looks like if I grabbed a hold of this this decimal point and pushed it 3 place values back, it would land in between the 6 and the 5. And it creates a new version of the number, right? It creates the product 16 and 5/10. And we've practiced multiplying and dividing by powers of 10 before, sliding digits forwards and backwards on the place value chart. But today it gets just a teensy bit more difficult, where we have to take maybe a number that doesn't look exactly like a power of 10, like take a look at number 3. It kind of looks like a power of 10 because it has zeros on the back, but it doesn't look like a power of 10 because there's a digit different than 1, right? 300. We are going to use this technique called decompose, which means to take apart, right? We're going to take apart the 300 into intentional pieces. So we want to take it apart into a power of 10 times something else. So how could you decompose 300 so that it looks more like a power of 10? What's one thing that you could split it into? What do you think? What could we split 300 to so that it behaves more like a power of 10? And I can't see whose hands are up, so go ahead and unmute.
103.
Exactly, yeah. So we're going to take our understanding of what 300 means, but we want to sort of rewrite it. We're going to decompose it to be something more helpful. We know how to multiply when there's decimals and a power of 10. We just bump the decimal point, right? We know how to do that part. So let's use that to our advantage when we see a number that takes on this shape where it looks like a power of 10, but it has a different front digit. It looks like a power of 10, but it has a different front digit. Do you see? So let's warm up a little bit with some of the easier ones, the ones that only have powers of 10 attached to them. We're going to warm up with those. And then we will go back and manage the ones that have to be decomposed. Does that make sense, everybody? All right. Number one, I see that we're multiplying the decimal 5 and 73/100 times 100, which is equivalent to 10 to the second power, which means I have to move 2 place values. Remember, the amount of zeros in a number sort of dictate how many positions that it changes that number by, right? So this number 100 changes the position of these digits 2 places over. We want to shift it into 2 place values over. So take that decimal point and shove it 2 place values over. And the new location for it is going to be after the 3 now. So this new product is 573. The decimal point is still there, but normally we don't write it unless there are more digits to come. It's not wrong, it's just not commonly practiced. I mean, have you ever seen on your birthday cake, you turn 10 years old and there's a decimal point after it? Have you ever seen that before? No. So you don't have to put a decimal point after a whole number like that, but know that it is there. It's just unneeded to be put when you end up with a whole number. All right, next one. How many positions would we move for 10 to the third power? That's sort of the same thing as saying 1,000. How many place values would we shift the decimal point, class? How many place values? What's the exponent here? What does it tell us?
3.
3.
Yep, 3 decimal places. We want to shift it. So put your pencil point at the decimal point and say, I like to move it, move it, move it. You know that song? I like to move it, move it. I like to move it, move it. That's what I want you to think about when you're doing this type of work. All right, how about this one? How many place values am I moving for just plain old 10? That's the same as 10 to the first power. How many place values?
1.
1.
So take the decimal point and bump it 1 position, and it changes that decimal location to be in between now the 1 and the 3. How many positions am I moving here? Oh boy, 5. That's the same as saying 100,000, right? 5 positions. So it looks like I have only 3 available digits. How do I move 5 if I only have 3 digits? I have to keep moving that decimal point, but what do I put in those empty spaces, do you think?
0.
Placeholder zeros, yes, because I want my number to be in the correct place value. And the only way that happens is if I put these numbers, these zeros, in the spots they need to go. So now my numbers are in the correct position, 314,200. Come on down to number 7. How many positions am I moving here? 4 zeros means 4 positions. So let's move it forward. 1, 2, 3. I need one more. Build in a placeholder 0. 130,980. Ooh, we're moving 6 positions this time. Here we go. 1, a 2, a 3. I need to add some zeros. 4, 5, 6. So I have to add in 3 zeros on the back, causing that number to adjust to be 9,000. Now, these are all multiplication, right? And the numbers, the decimals, they're becoming bigger. What do you think would happen if we were dividing by these very same numbers? What do you think would happen? What goes on? How is multiplication and division related? So if multiplication makes the number bigger, what do you think division does? Does someone have another? Anyone have an idea? All right, I'm going to say it again with some different language because I really want you to get this connection here. When I multiply a number by a power of 10, it goes into bigger place values, right? It gets bigger. What would happen if I divide by a power of 10?
It will get smaller.
It would get smaller. So those same digits would get pushed in the opposite direction. Does that make sense? So when I'm multiplying, they get bigger. When I'm dividing, they get smaller. But do the digits themselves change or do they just move? They just move position, right? Good. All right. Look at number 10 for me. What number would this need to be in order for this number to change into this number? I can see it's getting bigger. So I know multiplication times power of 10 is what's going on. That's what's happening. If it's getting bigger, bigger how? By how many place values? What changed between this number and this number? You know the decimal point is right there, right?
2.
2 place values. So what power of 10 means 2 place values? 10 to the first, 10 to the second, 10 to the third, 10 to the fourth.
10 to the second. 10 to the second.
I could also say 100, right? 1.57 times 100 would cause it to go, I like to move it, 2 place values, and it would change into this number, right? So we have tested it. It works. You can put 10 to the second, or you can put 100. Both of those answers are correct. How about number 11? How many positions does the decimal point move in order for it to turn into this new number?
2.
Let's see. 1, 2.
3.
It would have to be a little bit more because that would just be 560. We need one more place value built in there, right? So how many?
3.
The third, you got it. So that would be 1,000. All right, same technique, just a different order. Don't be bothered by that. Multiplication is commutative, so it's okay to reorder these terms. What number would cause 2.089 to turn into 208.9? How many positions would it have to move in order for that to happen?
2.
2 place values. So that would be 100, right? Or 10 to the second power. All right, now on to the trickier material. The trickier material involves saying, wait a minute, that's not a power of 10, but it's a version of it. Let me decompose 300, just like you told me earlier, into 100 times the digit it represents, and then just drop down the rest. All right, which part do you want to work on first? We have to go from left to right. So let's underline the part we're working on.
Miss Moore,
Yeah.
what page are we on?
Oh my. 195.
Oh, we're still on that page. What question?
Number 3. Oh, you must not have your stuff with you.
I have it. I was just confused, like what you were talking about. But I'm on page.
Were you writing these down on a paper somewhere?
Yeah, I have them in my list.
Okay. All right. Anyway, back to number 3 here. Everyone can see what I'm writing, correct? Okay. What would 6.1 times 100 be? I would have to move it 2 place values, right? Because 100 means move it twice. So what would 6.1 turn into? Turn into, we need to add in a placeholder, turn into 610, right? Drop down the times 3. Now we can handle this 610 times 3 off to the side if you want. 610 times 3. Did you get 1,830? It's a lot to smush in that little space there. 1,830. That'll do it. So here, I'm going to put number 3, 1,830. But on your paper, I should see all of this calculation business, okay? I'm just going to kind of relocate it so that I can move on to the next problem. All right. On this next problem, would you do me a favor and change the 500 into a 5,000? Can you change it to 5,000? Thank you. All right, now let's get to it. We have to decompose that 5,000 to show what? We want it to act like a power of 10. So how can I reorganize the way that it looks? How can I decompose it? Anybody?
10, 4, 10, 5, or
I want it to look like a power of 10. So I need it to have zeros on the back. And we're going to kind of peel off the 5. What times 5 would make 5,000?
1,000.
1,000 times 5. Okay. So basically we just took apart 5,000 into 2 factors because we know that if we use a power of 10 on this decimal, it's just a matter of moving the decimal point and there's no calculation involved. Right? So let's underline that part. We're going to work on that part next. And that's just, I like to move it. How many positions are we moving the decimal when we're multiplying times 1,000? How many positions, class? Show me with your fingers. Yep, thank you, Tegan. 3 positions, right? Because it's 1,000 and there's 3 zeros in 1,000. So move it. Turns it into 624 times, don't forget about the 5. So I don't know what 624 times 5 is, so I better calculate it off to the side. So the final answer there, 3,120. Are you okay with that one? All right. Let me grab my eraser here. I really wish your book would leave you a little more space. What could you decompose 6,000 to be? So that it could help you bump the decimal point. How could you decompose 6,000?
6 times 1,000.
Yes. So let's rewrite the whole expression. Put the 1,000 next to the decimal times 6. Are you writing this down on your workbook? All right. And then underline the part we're gonna do next. How many positions we move that decimal?
3.
A 1, a 2, a 3. Changes it to 831 times 6. Well done. Now last piece is to figure out what that's worth. 831 times 6. We always do our calculation work off to the side, get it out of the way. And then plop our answer in the position it belongs. How are we doing with that one? God bless you, Tegan. So there's a couple on the next page, on the homework page, that I want to tweak a little bit. You know how I had you add a 0 onto that one, and I'm going to help you decompose some of them. So when we're ready, I'm going to clear this page and move on to the next page. So just give me a thumbs up if you're ready for me to scoot to the next page, okay? All right, all right, all right. Looks good. Okay, so let me clear this out. I'm going to scroll down here. So let's just kind of preview it first. Don't write just yet. But do you notice how number 1 has a power of 10? That's easy. Number 2 has a power of 10. That's easy. Number 3 is going to have to be decomposed, right? What would you decompose number 3 into? What would you decompose that into so that it acts and looks like a power of 10?
9 times 10.
Okay. For this particular problem, I would like you to change this to 9,000. Can everyone change it to 9,000? Which would change it into 1,000 times 9, okay? Can you change that right now on your paper? Thank you. And I'm moving forward here. I see number 4 is a power of 10. That's easy. Move it 3 times. Oh, move it 8 times. You're probably going to have to add some zeros, right? Number 6. Oh, hold up. We don't have a power of 10. We can decompose it and make it a power of 10 though. How? 1,000 times what?
Times 2.
Times 2. Yep. We just drop down the rest of the expression so that we can kind of go after it with order of operations, right? Good. So we got those structured. 7, 8, 9 are good. Number 10's good. Let me look down the page just a touch. Let's set up number 11 together. So Mr. Jackson buys 3 boxes of graham crackers, 3 boxes. There are 200 packs in each box. So imagine 200 in one, then 200 in another, then 200 in another, which makes how many packs altogether, everyone? So if there's 3 boxes and there's 200 packs in each.
600.
600, yeah, 600. So there's 600 packs inside of those 3 boxes. So I can even make myself a little note, right? Each pack contains 0 and 23 thousandths of a kilogram of graham crackers. What is the total weight of all 3 boxes? So we know there's 600 packs, and we know that this is the weight of each pack. So we can set up an expression that says, well, I'm going to multiply the weight of 1 times the weight of how many I have, right? And then this is going to be a situation where you have to decompose the 600 in order to solve the problem, okay? I want you to cross out number 12 and cross out number 13 for today. So you're working on 1 through 11 for me, all right? So we did 195 together. If you're on this Zoom here with me, you only have to upload page 196 to your homework, okay? Does that sound good? And tomorrow we'll work out a little bit on some multiplication fluency. But other than that, have a really, really great spring break. And it looks like if you're sticking around Michigan, which I am, the weather's actually supposed to be nice for once on spring break. Normally it's rainy and 45 degrees and super cold, and then everyone comes back looking sunny and tan, and it's supposed to actually be pretty nice in Michigan. So that's something to look forward to. But I hope you have a blessed Easter and enjoy some time with the people that are in your life, and enjoy some time off school, right? Once we get back, it's the home stretch. Just one more quarter, and then you'll be in 6th grade. Pretty cool. Well, I'm going to hop out of here. I have another class to pick up soon.
Miss Moore,
Uh-huh.
do we have a Zoom tomorrow?
No, I didn't have a Zoom planned because we have kind of an unusual day. You know how you have that book bingo thing going on tomorrow? We have really short classes. So what you're doing on your math assignment is for sure something that you can understand on your own. You're doing 1 and 2 digit multiplication. And then this is just a fun little Easter connection, like kind of a brain puzzle connected to it. Esther?
I don't have a question. I was just making
okay. Oh, okay. All right. Well, I will see you guys later, okay? I'll see you after Easter. And we'll start our survey project, okay? Bye.
Bye, Miss Moore.